So I just finished making and editing the video, and after doing so, I realized just how much better this would be in class. Hearing your ideas, hearing the conversation, having you say, "This is what doesn't make sense. This is why we should do it this way." I miss all that stuff so much, and I think this assignment is still pretty good and definitely worth doing. But it's also really obvious to me that it's nowhere near as good as it would be in class. And I just want to say that I miss you, and I miss being at school, and I miss the routine, and I miss learning so much from everybody every day. And I haven't said that clearly yet, so that's how I feel. Anyway, here's the video. Greetings, Earthlings. Today's problem is about Earthships. But before we get to today's problem, I want to talk about two other things. First, work submission from last week. Thanks to everyone who submitted it, gave you feedback today. A lot of you asked me questions last week, as I mentioned in another video, but haven't submitted anything. Please submit it. If it's only partially completed, that's fine. If you're not sure what to write, put that. But I think there's more work out there than I've seen, so please get it to me. This hat, some of you may recognize it, is the logo for the Washington Wizards NBA team. It says DC, but it also, to me, looks like, trying to trace it there, CLC, which is a class at Cortland that I used to teach. So when I saw this logo one time, I thought, that looks like CLC. I went on and bought a discount Washington Wizards hat. So on to the problem. This week's problem comes from this book. It's called Math That Matters Too. It's by a teacher in Toronto named David Stocker. And what it does is all the problems of this book combine math with social justice, and he teaches a grade 7-8 class in Toronto. I got it in early March, and then we stopped, so I'm trying it out this week, and hopefully we'll see more of it in weeks to come. So if you go to this assignment, which is posted as its own assignment in Google Classroom under classwork, you'll see the assignment about Earthships with a little bit of background info, and you know that they are houses made of dirt, tires, broken glass, kind of stuff that would otherwise be ending up in a landfill to make a house. And as you're working on it, you really need to think, does this make sense? Does this seem sustainable? Is this something you might want to do? Garbage, tires, broken glass, but less resource intensive. Consider, is this a good plan? So I've got a little intro here, but I'll let you read that yourself. As you go through these slides, 2, 3, 4, 5, anything in red is for grade 8s only, or people who did the volume of a cylinder, area of a circle stuff on Khan Academy. So that's the way to differentiate between grade 7 and grade 8. Next up, this is a diagram. This is taken from this book. And I just showed it's very rudimentary, but it is connected to this next water question. The first question here is about that diagram. So you need to use that diagram, and you can either explain your answer with words, or feel free to use this diagram and put arrows on it with little annotations, or make a video. Either one is fine, kind of make it more interactive would be cool. Then this one, the question 2 here talks about water use. So 2A, I don't think I should need to explain it too much, but 2B, you will need to figure out what a roof will look like to hold a year's worth of water. That means all at once hold a year's worth of water. And in order to do that, you will need to figure out the volume of a shape. Doesn't matter to me what shape you use. If you want to use a rectangular prism, that's fine. If you want to use a cylinder, that is also fine. If you want to get creative and make the roof a triangular prism of your Earthship, that's fine with me as well. But you will need to make a shape like that and figure out what the dimensions are. Now, you obviously have to convert liters, which is what the water use measurement is, to a different unit for volume, knowing that 1 centimeter cubed is 1 milliliter, or that 0.001 meters cubed is 1 liter. So you'll have to play around a little bit with the place value there in order to make sure that your dimensions for your roof match the quantity of water used. On to number 3 right here. Would a cylinder 2 meter tall with a radius of 1 meter be big enough to hold a family's water for the week? That one is grade 8 only. Basically, I recommend sketching out the cylinder, figuring out the volume of the cylinder. The volume of a cylinder is pi r squared, which is the area of the circle on top, times the height. And how does that compare with a family's water for 1 week? Moving on to number 4, slide 4. The first one is about the walls. So there's a sketch of a wall. Rough sketch, 1 meter, 2.5 meters. And it tells you that a bottle with a radius of 5 centimeters, several of these bottles are going to be used to tile the wall. This is not to scale. How many of these bottles, radius 5, not diameter, radius 5, will they need to build this wall? And then in a real Earthship, this space in the middle would be filled in with clay, dirt, whatever. But we're just talking about the bottles. Then over to the next part. This next question asks about tiling or building a wall with tires. Here's a picture of a tire. And the thing about tires is they're like a cylinder, but the majority of them is air. So what you need to do is figure out what total volume would a tire take up, and then take out the empty space. And the way you can do that is a little sketch. So this is the side of the tire, which has a height of 15 centimeters. And then right here is the top view, part in the art. And this tire has a radius of 38 centimeters. And so you find the total volume of that tire, and then figure out what 75% of it is. And then from there, figure out, okay, how much dirt would I need to pack into that tire to use it to build a solid wall? And then the last part and the best part, your opinion. What do you think about these Earthships? Do they make sense? Are they reasonable? How do they connect to quality of life, grade 8s? How do they connect to resource use, grade 7s? Would you like to live in one? Do you think you'd be happy? Do you think it'd be annoying? I want to know your opinion on this last slide, and then submit it. And that is the assignment 8-7. Thank you for watching. Thank you for listening. I know a lot of you are having to go back and forth and pause and rewind. But please, things that aren't clear, things that you want clarification on, please post or email me, and I will do a follow-up video later in the week clearing up any of that stuff. So again, thanks for watching, but please post your questions and good luck, Earthlings.